All right, 11.7 is all just about strategies for testing series because we've learned quite a few different tests. Some sections had, one, some had two. Trying to narrow it down to which test we're going to use instead of, because it's not just going to be characterized into, use this one kind of thing. So obviously if you have like 1 over n to the p, that's going to be a p series.
All freshmen report to the little theater.
Yeah. Okay, so this gives you some hints in the back too. Obviously, if you see that it's a p-series, you can go back to, the p-series section, the p-series test, and look at that. But it's going to be convergent if the exponent's greater than 1, and it's going to be divergent if the exponent's less than or equal to 1. And think of it, okay, it's convergent if p is greater than 1. This is something you're going to have to memorize, right, which some of you might already have memorized. But if our exponent's greater than 1, doesn't that make the denominator bigger, right? So it makes sense that it's that way, right? So try to start making connections with it rather than just feeling like you have to memorize every little thing. If the denominator is bigger, the whole thing's getting smaller, so it makes sense that it would converge, right? So start trying to, memorize these without having them really memorize. Okay, second one is talking about the geometric ones. If you see that they're in this form, it's going to be geometric. The other way you can do it is what we talked about before, the rabbit method, listing out a few of them, and if you see you're always multiplying by the same thing to get the next one, that's going to be geometric. How do you find your R value then? Yep, it's just what you're multiplying by to get the next one, okay? So if it's, that's your sum. Yep, if you need to actually find the sum, you do the A over 1 minus R. I think so, yeah. Okay? Yeah, A over 1 minus R. Cool. Okay, but that's only if you're, thanks. Thanks. Okay, so you find your R value. If it's in this form, you can, see it in the form, but if you, do the rabbit method where you put a few of the values out, just see what you're multiplying by. And as long as the R value is, close to 0, so less than 1, the absolute value is, then it's going to be convergent. Okay, if it's larger than 1, you're multiplying by a bigger number, and the numbers keep getting bigger and bigger, so it doesn't make sense for it to converge. Okay, so that's 1 and 2. The third one, if we have something that's similar to a p-series, or it's similar to a geometric series, then you're going to use the comparison test. Most of the time, it seems like the comparison test is used and we compare it to a p-series. So if it looks like something that's like a p-series, that's probably what you're going to use, is that comparison test. Or if the comparison test doesn't work, that limit comparison test. Okay. This here, when comparing a p-series, we often keep the highest powers in the numerator and denominator. Remember that? Okay, and then you can kind of reduce it down. So that's kind of a way to go about doing the comparison test. And if you remember back, if we look back at the comparison test, it says they're series with positive terms, right? So here it says the comparison test applies only to series with positive terms. But if it has some negative terms, you can apply the comparison test to the absolute value of it and test for absolute convergence. Because what do you know if it's absolutely convergent? It's going to be convergent, right? So even if they're not all positive, just throw the absolute values around it and compare it that way. And then you can prove, okay, it's absolutely convergent, and therefore it's going to be convergent. Okay? Any questions so far? I know it's a lot of info, but you can kind of highlight this and stuff too, however you feel necessary. And I would definitely, use this kind of when you're starting, but try to, wean yourself away from it a little and then come back to it to make sure that, you did things right.
Are you going to know, the name of the test?
I haven't looked into that yet, but I'll look into that. Yeah, I'm not sure if you're going to have to say by the ratio test, but most of them are pretty easy, like geometric. Like that you're going to probably remember. And the p-series, you're going to remember that. Comparison test, well, you're comparing a sub n and b sub n, so I think the names are going to kind of end up being stuck in your head anyways. Alternating series, like, yeah, and then there's just the ratio and root test. And root test has the square root, so it makes sense, yeah. And the ratio test is really the only other one, isn't it?
Yep.
So,
Okay.
An integral test, you're using an integral. So, okay, cool. So, I mean, I would try to use, especially when you're, doing your homework, use the words for the test. But I would say on the AP test, if you don't know the name of the test, don't state it, unless it tells you to state it, then take a guess at it, But yeah, we'll look into that a little bit more. An easy one that you want to kind of check for right away is a test for divergence. If you take the limit of what's in your, series notation here, if you take the limit of that as you go to infinity and it doesn't equal 0, you automatically know it's divergent. So if you see that right away, that would probably be, something I'd just look for right away. And if you see that the limit doesn't equal 0, it's going to be divergent. And that would be like, okay, at a glance you notice that. It's not something where, you'd probably, sit down and try it every time and work really hard at it every time. Especially if you see it's in one of these other forms, But it's super easy when it, just falls into there. Number 5 then. If you have like -1 to a power, it's going to end up being alternating. So I would use that alternating series test. If the alternating series test didn't work, where else did we see a lot of the alternating things happening? Didn't we see it in like the ratio test when we did that a lot? So I mean, I would always try the alternating first because it's an alternating series. And that's probably going to be where you'll, where it'll work. But if it doesn't, the ratio test, because you're doing the absolute value, it kind of cancels that part out. So that would be what I would probably try next. Number 6, if it has like factorials, when did we see that? The ratio, right? Because with the factorials and the things start to cancel when you do your dividing, right? So if we have factorials or other products, we use that ratio test. I didn't end my parenthesis. It really bugs me. Let's see here. Keep in mind that if we have the a sub n plus 1 divided by a sub n, the absolute value of that approaches 1 as n approaches infinity for all p series and all rational or algebraic functions of n. So when your ratio test goes to 1, what happens? It's not conclusive, right? So if it's just a p-series, use the p-series test because it's not going to work with the ratio test. It's going to give you equals 1. So not that you might not do that by accident at some point, but it's just saying, it's not going to work with, it's not like you can just say, oh, I'm just going to use a ratio test all the time because it won't work for some things. But number 7 then. The root test, if we have something to raise to like the nth power, I would use the root test because it gets rid of that nth power. And then the 8th one here, the integral test, if you can see that, if I throw it in an integral and it's super easy to evaluate, I would definitely, use that one. So obviously some of this seems a little bit obvious, but we'll get there. All right, let's jump to these here. Just indicating which test we're thinking we should use. And then obviously in your homework you're going to have to use the test, but
Was there one? Or the second? The 783. Yeah.
okay, any of these that we think we know just right off the bat? This one here? Alternating probably, right? I'd probably use the alternating. Alternating series test. So this one we were thinking what? Ratio. Is this one geometric? So yeah, if we plug in 1, we would get 1 over 5, right? If we plug in 2, we would get, it's not really looking like it, right? It kind of looks like it with that, nth power comparison, and we could compare it with what? 1 over 3 to the n. So I would probably say, oops, I forgot my test there. The comparison test probably. I'll give you a second to look at those other ones. Yeah, it's not like it's super obvious all the time, but we're going to have to figure out which route we want to go when we're doing them. So.
Wow.
So let's look at our list
For
here.
the first one, do the task for divergence.
That's what I was just thinking. It doesn't go to zero.
Yeah, because if we take the limit as we go to infinity, it doesn't go to zero, right? So that would be a test for divergence. Good job.
I'm really proud of that.
I know.
I didn't know where I was going. I was like, oh, I'll take the limit. And I took it in my head. Now I suck at limits.
See, we're getting
No,
better.
it does.
Okay, so test for divergence. Everyone see that? When you take the limit, it doesn't go to zero.
Oh, that one.
I
It has to be the comparison because it's like
there's a lot of
highest.
stuff.
The highest degree with each of them, right? Which is a comparison test. So I would probably do a comparison there as well. And it doesn't mean that these are always going to work right away, you know, but at least we're starting to identify which ones we should.
Third one. I don't know.
Okay, look at what's in here. If I did the integral of that, couldn't I just use a u substitution? So there I would probably, you know, use an integral test possibly. Not that, you know, it's going to be super easy necessarily, but that looks, you know, easy enough to take the integral of. So maybe integral test. Another thing that the book suggested was the ratio test. So, because it's a product. I think that was, I don't remember which one that was. For number 6 there, it says series that involve factorials or other products, including a constant raised to the nth power. You see how that's that one? So integral test might be one you try, or the ratio test might be one you try, just depending. Okay. Now this isn't what your homework is. Your homework's not just saying to name them. You actually have to do them. But we've done all of these, so we should be able to. Theoretically, we should be able to do them. Yeah. They're all ones that are similar to what you've done. So, any questions on why we chose these tests? All right. Your homework is big, okay? 1 through 37 odd, because I want you to have a lot of practice with these, because that's, you know, all your test is going to be on. And when you're starting to do these, yeah, you might, you know, have to be using your sheet a lot when you're starting to do them, but really try to put the sheet away once you're starting to get used to, you know, which test there. I know now that we have them all together, it's kind of nice to have that for backup, but
I feel like with a little bit of practice, it's really not bad.
it's not, yeah.